Remember when the world of cloud infrastructure felt like, well, a chaotic, fragmented landscape? All
Yeah.
these disparate tools, custom-built solutions. It was kind of the Wild West, truly.
Oh, absolutely. A real mess.
But before something came along and brought a much-needed sense of order, you know, defining standards, allowing for incredible innovation on top of a stable foundation.
Yeah.
I'm talking, of course, about Kubernetes. It truly revolutionized how we manage containers.
Completely changed the game.
Well, what if we told you there's a remarkably similar revolution brewing right now, specifically for generative AI applications?
Hmm.
It's a foundational shift, a moment that feels very much like the Kubernetes for AI,
Yeah.
and it's really set to transform how we build intelligent systems.
That's precisely the parallel we want to explore today. Our deep dive is all about unpacking the Llama Stack project.
Right.
And this isn't just another open source tool. It's an ambitious and incredibly timely endeavor. It's designed to standardize and significantly simplify the development of enterprise-ready generative AI apps.
Especially those complex ones, right?
Exactly. We're talking particularly about those leveraging retrieval augmented generation, or RAG, to tap into custom data sources. And also sophisticated agentic capabilities, letting the AI actually take action in the real world.
So our mission today,
Yeah, our mission is clear. We want to understand why Llama Stack is so crucial for modern AI development, how it directly confronts and frankly aims to conquer the chaos that so many development teams are grappling with right now,
mhm,
and ultimately how it promises to make it genuinely easier to build AI applications that are not only robust and scalable, but also, importantly, remarkably portable across diverse environments.
okay, let's unpack this initial scenario then, because it
Mm.
truly sets the stage for why something like Llama Stack is even needed.
Right.
In the, let's say, nascent stages, building with AI models felt relatively straightforward, didn't it?
It seemed that way at first, yeah.
The process was often quite direct.
Mm.
You'd make an API call to a large language model, an LLM. Maybe it was running locally on your machine, maybe hosted securely in the cloud.
Simple enough?
And bam,
Yeah.
you get your inference. Generate text, summarize content, basic classification tasks.
It felt powerful.
It was exhilarating,
Yeah.
right? A tangible taste of the power of AI right at our fingertips. And for many, it seemed like, okay, the hard part's over.
But here's where the plot thickens, and it thickened really quickly.
Yeah, it always does.
What happened next was this burgeoning need to add all sorts of incredibly useful, but also incredibly complex features onto these, foundational AI applications.
It wasn't just about the inference anymore.
Not at all. Suddenly, we needed sophisticated data retrieval, often implemented through RAG, where we're querying vast vector databases, pulling in relevant context from internal documents, feeding that into the LLM to get these highly personalized, accurate responses.
Crucial for enterprise use cases.
Absolutely. Then the desire emerged to enable our AI applications to interact with the outside world, to execute actions, not just answer questions.
That's the agentic functionality.
Precisely. Which often involves intricate calls to various APIs, CRMs, databases, messaging platforms, you name it.
And then the quality control piece.
Beyond that, yes, the necessity for robust quality control became painfully apparent. We needed ways to measure the effectiveness, the reliability of our applications through rigorous evaluations. Are they actually doing what they're supposed to do?
Can we trust the output?
Exactly. And critically, especially in enterprise settings, we needed robust guardrails, things to prevent data leaks, ensure compliance with privacy regulations like GDPR or CCPA, and mitigate against generating harmful or inappropriate content.
And this, as I'm sure many of our listeners can attest, is where that initially simple scenario just utterly unraveled.
Completely. All these individual components, the RAG pipelines, the agent frameworks, evaluation tools, guardrail implementations, they often came with their own vendor-specific solutions.
Their own APIs, their own ways of doing things.
Exactly. Their own proprietary APIs, unique ways of doing things. Imagine trying to build a cohesive, reliable system when you're juggling like a dozen different tool sets, each with its own quirks, dependencies, integration challenges.
It sounds like a nightmare.
It quickly became incredibly chaotic, extraordinarily difficult for development teams to manage, to maintain, and crucially, to scale these applications effectively.
It's like trying to build a house where every single component, the bricks, the wood, the plumbing fixtures, comes from a different, incompatible manufacturer.
That's a great analogy, requiring custom adapters, endless troubleshooting. Just a mess.
So if you've ever felt overwhelmed by the sheer number of tools, frameworks, conflicting approaches in the generative AI space, trying to figure out the right way to integrate everything,
You are absolutely not alone.
yeah, this sprawling, fragmented problem, this AI Wild West, is precisely what Llama Stack aims to solve.
So the core idea with Llama Stack really is to actually bring all of this together, to wrangle that sprawling complexity into something manageable, something predictable. It's about standardizing these vastly different layers of a generative AI workload with a single common API.
A common API for everything.
Well, for the key functional layers, yes. And this isn't just about a unified interface. It's really about a foundational shift in how we approach AI application architecture, moving us towards a more modular, more robust future.
And the scope of this API is pretty broad, right?
Oh, incredibly broad. That's a truly compelling aspect here. This isn't just for some niche use case or a specific environment. This common API can run literally from a developer's laptop.
So for local dev.
Exactly, providing a familiar, consistent local development experience, all the way to the edge, processing data closer to its source in, say, a factory or a retail setting, and then scaling up to an enterprise data center, handling massive workloads, and beyond. It truly spans the entire spectrum of deployment needs.
Which raises the question, how does one API cover so much ground? How does it adapt to such varied environments and requirements but stay consistent?
Right, that's the key question. The answer lies in its design as a central hub. You could almost call it a central API to rule them all, maybe slightly dramatic, but you get the idea.
Ah, okay.
It allows users to plug and play with different components, effectively abstracting away the underlying infrastructure and those tricky implementation details.
So it hides the complexity.
Precisely. And this approach grants users immense choice and customizability, which, as we know, are absolutely critical for enterprise adoption.
Because enterprises have specific needs.
Exactly. Organizations often have stringent regulatory requirements. Think HIPAA, financial regulations. They have unique privacy concerns, specific budgetary constraints, maybe diverse existing tech stacks that dictate which models or data stores or cloud providers they can use.
Right. They can't always just pick the latest shiny thing.
Not at all. Llama Stack provides the flexibility to meet these diverse needs without locking them into a single vendor or technology stack. And this is fundamental. It's about moving from those experimental AI projects to production-grade, compliant, and cost-effective enterprise solutions.
That focus on standardizing layers and enabling true plug-and-play immediately brings to mind that strong parallel to Kubernetes.
Yeah.
And I think it really helps clarify Llama Stack's vision.
It's a very apt comparison.
Just as Kubernetes, roughly a decade ago now, defined core standards for managing containers, how they're deployed, scaled, networked.
Yeah, the primitives.
It allowed different vendors, different open source projects to provide interchangeable components. Think about it. You could have different container runtimes, various CI/CD pipelines, a choice of storage backends.
All plugging into the same standard.
Exactly, all adhering to the Kubernetes API. And this standardization fostered an incredible ecosystem of innovation and interoperability. It truly transformed cloud infrastructure.
And Llama Stack is very deliberately repeating this pattern, but for this burgeoning world of generative AI applications.
Okay.
It's establishing those core standards, those essential interfaces for the different functional layers of an AI application. And importantly, despite the name Llama Stack.
Right, it's not just for Llama models.
No, not at all. That's a common misconception. It supports any model that can run in popular inference providers. Think Llama for local development, which is fantastic, or VLLM for high-throughput production environments, and many other inference providers too, including various third-party hosted services.
That's crucial flexibility.
It is. And stepping back to consider the broader context here, the implications of such a standard are, well, profound. We can expect to see significantly faster innovation, right? Because developers aren't constantly reinventing the wheel for integration every single time.
Less plumbing, more building.
Exactly. It dramatically reduces learning curves. Engineers can rely on a consistent API regardless of the underlying components they choose to plug in.
Okay.
It leads to increased interoperability, allowing different tools and services to communicate much more seamlessly. And perhaps most excitingly, it fosters the potential for a richer, more diverse ecosystem of AI tools.
Where open source and commercial solutions can coexist.
Precisely. Coexist, integrate, and compete on features and performance, rather than getting bogged down in proprietary integration headaches. This just accelerates the entire field, making advanced AI capabilities more accessible and robust for everyone.
And to make this really concrete, Llama Stack defines key pluggable interfaces for those primary areas that were previously causing all that chaos we talked about.
Right.
We're talking about standardization specifically for inference, for agents,
Yeah.
and crucially for things like guardrails and evaluations. These aren't just buzzwords. These are the critical building blocks that, when left unstandardized, created so much friction and complexity for development teams.
Precisely. If we look at the bigger picture here, it's really about abstracting away the underlying complexity, much like an operating system abstracts away the hardware details.
Right. I don't need to know my exact CPU architecture to run Word.
Exactly. You don't need to understand the intricate details of your CPU or your memory management to run an application. The OS handles that for you. Similarly, Llama Stack aims to provide that operating system-like layer, but specifically for generative AI. It allows developers to focus on the application logic, the user experience, rather than wrestling with the minutia of model deployment or data retrieval specifics or tool integration across all these disparate systems.
It's a powerful shift.
It really is. It moves AI development towards more creative problem solving and less about tedious infrastructure plumbing. And this is particularly relevant for those critical, often overlooked areas like guardrails and evaluations you mentioned.
Let's dig into that a bit. How does it help with guardrails, for example?
Okay, so for guardrails, Llama Stack provides standardized APIs to integrate various safety mechanisms. Think about it. In an enterprise, you absolutely need to ensure PII. Personally identifiable information isn't accidentally exposed in prompts or responses.
Huge compliance risk otherwise.
Massive. You need generated content to adhere to brand guidelines or ensure models are protected against things like prompt injection attacks.
Which are becoming more sophisticated.
They are. Before Llama Stack, integrating these often meant bespoke code for each guardrail vendor or rolling your own custom solutions, which is time-consuming and error-prone.
Right.
With Llama Stack, you can plug in, say, a PII masking provider or a content moderation filter or a prompt injection detection service through a unified API. And crucially, you can swap them out as needed based on your evolving compliance requirements or the changing threat landscape without ripping apart your application.
Okay, so instead of writing separate integrations for every security feature, you get a common way to request those services. You choose the best provider for each specific need.
Exactly. It's a huge shift from a reactive custom coding approach to a proactive standardized one.
That makes sense. And it's not just about preventing bad things, it's also about ensuring quality, which brings us to evaluations.
Exactly. Evaluations are equally critical for enterprise AI. They allow teams to rigorously test and improve their applications over time.
How do you know if your RG system is actually pulling the best documents?
Right. Or how do you measure if your agent's actions are effective and accurate? Is it actually updating the CRM correctly?
You need metrics?
You need metrics and repeatable tests. Llama Stack provides standardized interfaces for integrating evaluation frameworks and tools. This means you can run comprehensive tests, compare the performance of different models side by side, or track key metrics like factual accuracy, fluency, safety, all through a consistent API.
So you could plug in different evaluation tools easily.
Yes. For example, you could plug in a provider that specializes in semantic similarity evaluations for your RG system. And then later, maybe you swap it for a different one that focuses specifically on hallucination detection without rewriting your core test harness.
Oh.
This level of standardization elevates evaluations from being an afterthought, which they often are, unfortunately,
Bad but true.
to being an integral, seamless part of the AI development lifecycle. It helps ensure that enterprise AI applications are not only built quickly, but also built reliably and responsibly.
Okay, let's really see how this works in action. Because that's where the power of this standardization, especially around those guardrails and evaluations we just discussed, becomes truly apparent.
Let's ground it.
Yeah, to truly appreciate its power, let's step into a common real-world scenario, one that many of our listeners are probably grappling with right now. Building an AI that can intelligently converse with your organization's vast internal documentation and proprietary data.
The classic enterprise chat use case.
Exactly. This almost certainly involves using retrieval augmented generation, or RAGE, remember, that's pulling in your custom context-specific data to ground the LLM's responses.
Making sure they're accurate, relevant, based on your knowledge base, not just generic internet stuff.
Right. preventing those generic, sometimes wrong answers.
This is precisely where Llama Stack shines differently from other approaches. It doesn't try to dictate how you perform RAG or how you run a specific model.
It's not prescriptive.
No. Instead, it provides a set of commonly used, standardized APIs. For instance, you get an inference API for the ability to run various models. You get a vector I/O API for the ability to search and interact with a vector database. And there are others for things like embedding generation, text processing, and so on.
Okay.
The crucial distinction here is that the API itself doesn't know how to perform the actual task. It's not the engine itself.
Cool.
Instead, it provides a consistent, agnostic way to ask for it. It's like a universal remote control. It doesn't care if your TV is a Sony or a Samsung.
Right, it just has the standard buttons.
Exactly. It just gives you the standard buttons for volume up or channel change. It abstracts away those vendor-specific complexities underneath.
And that's where the API providers come in. These are the specific implementations, the actual engines doing the work.
Precisely. If the Llama Stack API is your universal remote, the API providers are the specific TV brands or cable boxes that receive those standard commands and actually execute them.
Really?
They are the tangible, concrete technologies that fulfill those abstract API requests.
So give us some examples of these providers.
Okay, sure. Let's look at the inference API. Your provider could be a Llama, which is fantastic for local development. It lets you run a wide range of open source models right on your machine, perfect for rapid prototyping, testing, no network dependencies.
Great for getting started.
Definitely. Or if you're ready for production-grade performance and scalability, you might choose VLLM. It's known for incredible speed, efficiency, and batch processing, serving multiple requests concurrently.
Okay.
Alternatively, you might opt for a third-party hosted service, maybe like Grok, for example, if that aligns with your operational strategy and you prefer a managed service approach. Each offers distinct advantages.
And for the vector database part, the vector I/O API.
Similar idea. Your vector provider could be something like ChromaDB. It's a popular, lightweight, open source option, really easy to get started with. Or perhaps Weaviate, another robust vector database that offers more advanced search capabilities and scalability for larger data sets.
So you've got choices, which immediately raises an important question.
Yeah.
Why does this flexibility matter so much beyond just having options?
That's a great question. It's not just about choice for choice's sake. It's about strategic agility and long-term viability.
How so?
Well, different organizations have different infrastructure, right? Different compliance needs, varying performance requirements, and crucially, different budgets.
Always the budget.
Always the budget. The ability to choose the right provider for each specific layer of your AI stack, whether it's for specialized hardware support like specific NVIDIA GPUs or existing contractual obligations with a cloud vendor, or simply the best performance characteristics for a particular workload that's a game changer for enterprise adoption.
So you can optimize across different dimensions.
Exactly. Optimize for cost, performance, compliance, all at once. It lets you tailor the stack precisely to your needs.
And this brings us to what feels like the core benefit, the really crucial advantage of Llama Stack. You can plug and swap out these different providers against the Llama Stack API.
Without changing your actual source application code.
That's the kicker right there.
That's the magic. It's incredibly powerful because it dramatically reduces the risk and the effort associated with technology shifts or upgrades.
Give me a practical example of that swap.
Okay, imagine this. Maybe you start developing your RH application locally. You're getting things up and running quickly on your laptop, using a Llama as your inference provider and maybe ChromaDB for your vector store.
Quick and easy iteration.
Exactly. Fast, cheap to iterate. But then when you're ready to move that application into a production environment that demands higher throughput, robust management, maybe integration with a broader enterprise data platform,
Right.
you can switch to using VLLM as your inference provider and perhaps Weaviate as your vector store with literally just a single configuration line change.
Wow, not weeks of refactoring.
No, that's not just a time saver. It fundamentally alters the deployment and scaling lifecycle of AI applications. We're moving from potentially weeks of complex refactoring work to minutes of configuration adjustment.
That is huge.
Absolutely. And this isn't just about convenience. This is about strategic flexibility and long-term sustainability for your AI initiatives.
Explain that a bit more.
Well, you might need to work with specific providers due to a whole range of factors. Maybe you have specialized hardware like those NVIDIA GPUs we mentioned that certain providers are highly optimized for. Or you're required to use specific on-premise infrastructure for security or data sovereignty reasons.
Or contracts.
Or there might be existing contractual obligations with the cloud vendor or a specific data provider you have to use. And of course, performance and costs can vary wildly between different providers.
Right.
The ability to make these changes without touching your core application logic provides an unparalleled level of adaptability and, frankly, future-proofing.
Your application isn't brittle.
Exactly. It's not brittle. It can evolve with your infrastructure, your compliance needs, your business strategy. I still have nightmares about a project last year where we had to maintain 3 different sets of integration code because the client had this mix of on-premise, Cloud A, and Cloud B environments.
Oh, no.
Llama Stack would have turned that 3-week integration headache into a simple configuration change. It really changes the game.
And to make this even easier, Llama Stack also introduces something called Llama Stack distributions, or distros.
Yes, exactly. Think of these as prepackaged, curated collections of providers. They're designed to work seamlessly together right out of the box, making the initial setup and deployment process much simpler.
Like a starter kit.
Kind of like a full-stack starter kit, yeah, tailored for a specific environment or use case.
What are some examples?
Well, these distros cater to different deployment scenarios, greatly simplifying the onboarding. For example, you could have a locally hosted distribution. Everything you need inference provider like a Llama, a local vector database, runs right on your machine. Perfect for rapid development, testing, no network dependencies needed.
The laptop setup.
Exactly. Or you might choose a remote type of distribution. This is where you're working with third-party APIs like a hosted LLM service by simply providing an API key in the configuration.
So you don't run the model yourself.
Right. Llama Stack manages the interaction with that remote service via the standard API. This flexibility means you're able to test your AI application, say on a mobile phone, take it to the edge for localized processing in a factory or retail environment, or push it to full production in a major cloud environment, often with just a simple configuration edit.
That drastically lowers the barrier.
It really does, lowers the barrier to deployment and iteration, enabling developers to focus on the AI logic rather than the complex orchestration of all the underlying infrastructure pieces.
That agility, as you just touched on, is what truly differentiates Llama Stack.
Yeah.
Given your perspective on the industry, what kind of immediate challenges do you think this solves for an AI development team? Especially for those early stage proofs of concept that often get stuck in pilot purgatory.
That's a great point, pilot purgatory. I think the most immediate benefit is slashing the time it takes to go from an idea to a deployable prototype.
Speeding up experimentation.
Massively. Think about it. A team identifies a business problem where AI could help, say, summarizing customer feedback emails. Before Llama Stack, they'd potentially spend days, maybe even weeks, just deciding on which LLM, which vector DB, how to connect them, getting credentials, and then coding all that glue logic.
The setup overhead.
Exactly. With distros, especially the local ones, they could potentially spin up a fully functional, albeit local RH application in an afternoon. This accelerates that crucial validation phase. It helps teams quickly determine if an AI solution is even viable before they invest heavily in it. It really tackles that pilot purgatory problem by making experimentation far cheaper and faster, pushing more promising projects towards genuine production deployment.
Okay, now let's come back to our example from earlier. We've built this robust RJ application for internal documentation using Llama Stack. But our team needs more. We need to add even more advanced capabilities.
Moving beyond just Q&A.
Right. We want our AI to be able to take action in the real world, to actually do things. We need agentic capabilities. Maybe we want our AI to retrieve specific real-time information from a company database.
Like current inventory levels.
Yeah, exactly. Then maybe update our CRM system with a summary of a customer interaction it just had. Perhaps even send a notification via Slack to the relevant sales team or, any number of other integrated actions.
So moving from merely querying data to actively interacting with and automating business processes.
That's the goal.
And this is where Llama Stack continues to shine with its standardized approach. It extends that same modularity we saw with models and data stores to these external actions or tools. With Llama Stack, its APIs and its flexible provider ecosystem, you're able to build an agent that uses predefined tools to interact with the outside world.
Right.
And what's truly compelling here is precisely how it achieves this. It does it without tying your agent's core logic, its reasoning capabilities, to the specific implementations of these external tools.
Maintaining that separation.
Exactly. It maintains that crucial separation of concerns that is absolutely central to the Llama Stack philosophy. The agent's intelligence remains focused on reasoning, planning, deciding what action needs to be taken.
While the execution is delegated.
Precisely. The execution of those tasks is delegated to these interchangeable tools, which abstract away the specifics of how that action is actually performed by the external system.
And the mechanism for this involves something called MCP servers, Model Context Protocol.
Yes, that's right. Llama Stack utilizes Model Context Protocol, or MCP servers, to define these tool groups. It's essentially a standardized way of exposing functionality to your AI agent.
Like an API for tools.
Kind of, yeah. Think of it as a defined abstract contract for how your agent can request external actions regardless of the underlying system it needs to interact with.
So the agent doesn't need to know the Salesforce API details.
Exactly. It's not about the agent knowing how to use the Salesforce API specifically, but knowing that it can perform an action like update CRM record through a standardized command defined by the MCP server.
Okay, so the MCP server acts as an adapter.
That's a good way to put it. It acts as an adapter or a translator. It translates those standard protocol requests coming from your Llama Stack agent into the specific API calls needed for, say, a Postgres database for data retrieval and updates.
Or Slack.
Or a Slack channel for sending messages. It handles the specifics for each tool. So you could conceptually have one MCP server that's specifically defined as a tool group for interacting with your Postgres database. It handles all the SQL queries, updates, etc. in a standardized way for the agent. And you could have another MCP server specifically for Slack, managing messages, channel interactions, and so forth, again, presenting it to the agent through that unified interface.
And you register these just like the inference or vector providers?
Exactly the same principle. Just as we registered providers for inference or for our vector databases, you register these tool groups implemented as MCP servers with Llama Stack.
And this is critical because
it keeps the core Llama Stack philosophy intact. Your agent's code, its core logic, remains decoupled from the specific tool's implementation. This is incredibly powerful for maintainability and flexibility down the line.
Because your agent isn't hardwired.
Exactly. It's not hardwired to a particular database technology or a specific messaging platform like Slack versus Teams or a specific CRM vendor like Salesforce versus HubSpot.
It's a huge benefit for long-term development, surely.
Massive. It means you can swap out a database provider. Maybe you migrate from Postgres to MySQL. Or you upgrade your CRM system from one vendor to another. Or you decide to switch your company's communication platform.
Right.
Or maybe just the API for an existing tool changes. You can handle all of that by updating the relevant MCP server without needing to rewrite your agent's fundamental logic or reasoning capabilities.
The agent's core intelligence stays stable.
Exactly. While its external interfaces, the tools it uses, can evolve and adapt along with your business needs and technology choices. This drastically reduces the technical debt and the maintenance overhead often associated with these complex, highly integrated AI systems.
It lets enterprises respond faster.
With unprecedented agility, yes. It fundamentally changes the cost of change for these systems.
And in terms of actually building these agents, how does Llama Stack help? What are the options?
Well, Llama Stack provides flexibility here too. You could opt for a simpler approach like prompt chaining, where you guide the agent through a sequence of steps using structured prompts and calls to these predefined tools. Or you might take a more manual, perhaps declarative approach, defining explicit actions or workflows for specific triggers or user inputs.
More control.
More explicit control, yes. And for those looking for greater autonomy, you could even build something like a React agent that's React reasoning and action, a type of agent that leverages sophisticated reasoning capabilities to dynamically select and use the available tools.
To achieve a goal.
Exactly. It could act autonomously to bring necessary information into your AI application or execute complex multi-step tasks involving several tools to achieve a high-level objective.
Stepping back, thinking about the broader context. Imagine the possibilities for truly complex enterprise workflows.
It really opens things up.
This isn't just about AI answering questions anymore. It's about AI taking proactive action, automating multi-step tasks that span different systems, integrating seamlessly into existing business processes.
How will this fundamental shift change how we think about automation in the workplace? It pushes the boundaries from simple task automation, like filling out a form, towards intelligent, adaptive workflow orchestration.
Where AI is an active participant.
An active participant in business operations, not just a passive helper. It could coordinate tasks between humans and systems, optimize processes on the fly. The potential is huge.
That's a fascinating vision. The modularity sounds incredibly robust. The vision is compelling. But, every groundbreaking technology faces hurdles. What are some of the common misconceptions or maybe initial challenges teams encounter when they first start implementing Llama Stack?
That's a crucial question because, yeah, no technology is a magic wand.
Right.
One common misconception is that Llama Stack is just another framework you learn. It's really more of an architectural philosophy that comes with an accompanying API and a set of tools.
So it's a mind shift, too.
It is. The learning curve isn't necessarily about mastering a new coding language, but more about adopting this new way of thinking about AI application design, really embracing modularity and abstraction from the start.
Okay.
Developers, particularly those used to more monolithic architectures or very bespoke integrations, might initially find it a bit challenging to fully decouple their application logic from specific provider implementations.
They might try to work around the abstraction.
Sometimes, yeah. They might try to sort of force a specific provider's unique features or idiosyncrasies through the Llama Stack API instead of fully embracing the abstraction layer it provides.
Gotcha.
Furthermore, while Llama Stack aims for seamless swapping, you always have to remember there can be subtle performance differences or feature nuances between different providers.
Right, they're not identical underneath.
Exactly. For instance, a vector database designed for massive scale might have different indexing behaviors or query latency characteristics than a lightweight local one. Llama Stack provides the interface for swapping them easily.
But you still need to know the tools.
Yes. Developers still need to understand the characteristics of their chosen providers to optimize effectively for their specific use cases. It shifts the problem, maybe, from how do I integrate these disparate things to which interchangeable component best suits my current needs. A different kind of thinking, but still an important consideration. It requires a bit more upfront architectural thought, perhaps.
Those are really important considerations for any team adopting new tech. It's not just plug-and-play magic. There's still thought required.
Absolutely.
But, okay, stepping back again. At the end of the day, whether you're an AI engineer deep in the models, a developer building the actual applications, or maybe a platform engineer managing the underlying infrastructure.
All stakeholders in the AI lifecycle.
Right. We're all trying to achieve the same overarching goal: to build robust, secure, and scalable enterprise-ready AI systems. It's really about moving beyond those endless proofs of concept, beyond pilot purgatory, to reliable production-grade applications that deliver real, measurable business value, and doing so efficiently.
And the core idea, the promise of Llama Stack, is precisely to give you full control to run your own generative AI platform tailored to your needs without having to build absolutely everything completely from scratch.
Which is key for enterprises.
It's absolutely crucial, especially for those organizations with stringent regulatory requirements or complex security postures. You need to contrast this with relying on monolithic, often opaque third-party AI services.
Where you might give up some control.
Often you do. You might give up a degree of control over your data, how exactly your models are run, or even where your sensitive data resides geographically.
So what does full control really mean in this context?
Well, full control truly entails several critical aspects for an enterprise. First, it means data sovereignty, ensuring your sensitive customer or proprietary data stays within your controlled environment, doesn't leave your jurisdiction unintentionally.
Huge for regulated industries.
Absolutely. Second, it means adhering to your specific security protocols, your auditing requirements, your internal governance frameworks, not just accepting a vendor's blanket statement.
Okay.
And third, it means the vital ability to integrate seamlessly with your existing systems and infrastructure, which often includes legacy systems that aren't going away anytime soon.
Right.
Llama Stack provides that foundational layer, giving you the power to manage your AI stack according to your rules, while still benefiting from open source standardization and the innovation happening in the ecosystem. You get the best of both worlds, really.
And this shift has a profound impact on where development teams can actually direct their energy.
Oh, massively.
Right.
Instead of worrying constantly about the intricate details of supporting 3 different vector stores because of historical reasons,
We've all been there.
or wrestling with the nuances of integrating 5 different types of APIs and managing all their unique versions and update cycles, Llama Stack allows teams to refocus precious energy on actual innovation.
Building new features, not just connecting pipes.
Exactly. It frees up developer time from that tedious plumbing work and those deep infrastructure concerns, enabling them to concentrate on actual feature development, on creating novel AI experiences for users, and on building truly scalable but also profoundly portable AI applications.
Let's talk about that portability. Why is that so important?
Portability is key. It's the ability to move your application easily across different environments, maybe from your local machine to an on-premise data center for certain workloads, to various cloud providers for others, maybe even to edge devices.
Without major rewrites.
Ideally with minimal friction. This ensures flexibility and, crucially, helps prevent vendor lock-in, which is a massive strategic advantage in today's rapidly evolving tech landscape. You're not tied to one cloud-specific AI services or infrastructure.
It's really moved from being an integration specialist, maybe, to being more of an AI solution architect.
That's a great way to frame it, focusing on the higher level design and value, less on the low level connectivity.
And from a practical deployment perspective, how does Llama Stack fit into existing workflows?
Well, it's designed to integrate smoothly. You can easily use either Docker or Podman standard containerization tools to run Llama Stack locally with containers.
So familiar tools for developers and ops teams.
Exactly. This speaks directly to existing developer familiarity with containerization technologies and the infrastructure capabilities many organizations already have in place. It makes adoption smoother, reduces the learning curve specifically for deployment.
They're not learning a whole new deployment paradigm.
Right. It means engineers aren't just learning a new AI framework. They're deploying it using tools and practices they likely already know and trust, leveraging their existing CI/CD pipelines and DevOps workflows.
So you get consistency.
You get consistency in deployment strategies, whether you're working on a developable laptop, testing in a staging environment, deploying to the edge, or pushing to a large enterprise cloud. The underlying containerization approach can remain largely the same.
So think about the projects you, our listener, are currently working on. Or maybe the challenges you foresee in scaling and securing AI solutions within your own organization. How much faster could you move? How much more innovative could your teams be if that foundational chaos, the messy integration points, the vendor-specific complexities, the fear of locking yourself into one rigid stack was finally tamed?
Llama Stack really offers a pathway towards that more streamlined future, allowing your teams to focus on the what and the why of AI rather than getting constantly bogged down in the endless, how do I connect this specific thing to that specific thing? Hashtag tag outro.
So what does this all mean? We've taken a pretty deep dive into Llama Stack today. And what we've seen is how it truly offers something like a Kubernetes moment, but for the world of generative AI.
It's a powerful analogy.
It's about standardizing those disparate components we discussed, enabling that seamless provider swapping so you can adapt your stack to your needs, respond quickly to market changes.
And empowering those advanced agentic capabilities that can take real, meaningful action within your business processes.
Right.
It's really about transforming the often chaotic, fragmented landscape of generative AI development into something more structured, more controllable, and ultimately a more innovative environment.
Making it more mature.
Exactly. Knowledge is most valuable when it's understood and applied effectively. And Llama Stack provides a robust, standardized framework for that application. It moves us closer to truly enterprise-ready AI systems that aren't just powerful, but also reliable, maintainable, and adaptable for the long haul.
As AI continues to evolve at, frankly, breakneck speed, projects like Llama Stack aren't just tools. They represent architectural philosophies.
A way of thinking.
They argue for modularity, for standardization, for open ecosystems, and ultimately for developer freedom and focus.
Yeah.
So consider this provocative thought. If standardization and modularity are indeed the keys to scaling enterprise AI effectively, allowing us to swap out components almost as easily as we might upgrade a server or change a library, what new frontiers become possible when that underlying complexity is finally managed?
What could you build then?
Exactly. What might you build if the foundation for your generative AI applications was as stable, as flexible, and as plug-and-play as your container orchestration layer has become, thanks to things like Kubernetes?
It's an exciting question to ponder, and for those of you listening who want to dive even deeper and experience this firsthand,
Try it out.
We strongly encourage you to head over to GitHub or explore other sources online and actually try out Llama Stack for yourself. The best way to truly understand its power and potential is to put it to work and see the transformation it can bring to your own AI development workflow.